agenda in this last part of course is to do the theory of limits, differentiability, and integrals. Now we are ready to basically, we have created all that machinery which will allow us to basically rigorously define our limits. And so the first part, the next part that we are going to do, we're going to simultaneously do things from Rudin and Slaughter. There are some results which are in Rudin but not in Slaughter. There are some results in Slaughter which are not in Rudin actually. And what I would like to do is that you should do the exercises from Slaughter. Okay? There are exercises in Rudin as well. There are also really little, good exercises in Slaughter. So like do that and but you should go for those exercises. Okay? And really carefully do all these results that we are doing in this last part. Okay? And exercises, especially because these are going to be very important for exam as well. So let's begin with limit. What's the notion of a limit actually? So we'll do some of the results in metric spaces. Okay. So in general metric spaces, which are in any metric space, and but our focus should be on that metric space in particular the Euclidean metric actually. So now let's begin with. So I hope that we have defined function previously. So we can use and assume the notion of function. And we define it in the terms of a relationship. So a function is a relationship which has certain properties. Okay? We define it, so we're going to get into that again. But imagine I have a function f from a metric space x into a metric space y. Okay? Both are spaces. Both can be R, both can be Rn, be anything. Okay. And I would like to specifically define that what is the meaning of that a function approaches to a number, for example, say L as x goes to A. That's what the agenda is. I'd like to define that meaning of rigorous meaning of a function goes to L as x goes to A. Or the alternate notation for this could be limit x approaches to A f of x equal L. That's what we would like to define it. So give me a guess that how should we define it. So pictorially, if you like to see. Okay, imagine I have two spaces, so that's a space x and that's a space y, and I would like to define it. So, what are the meanings? If I take x here, and I have x is going to go between here. Okay, now what is the meaning of that? This value f of x and this value f of x is getting closer to a point. For example, L as x is getting closer to a point A. What's your guess? What should be the way to do it? In other words, we are somehow getting closer to A. Okay. So like if x is getting closer to A, then this point of x, not this point, but the values of the functions are getting closer to this point. What do you think that what should be the best way to describe this situation? I mean, if you like to see this on, say, for example, Euclidean plane or xy axis, so x is somewhere here, and that's your f of x axis. And what we are saying, and maybe you can place some point here, and L is some point here. Okay. So what are the meaning of x approaches to A? Okay, we can interpret it that x is getting it's like closer and closer and closer and closer to A. Okay. And in response, if A is this, then okay, f of L is somewhere here. Then the function is kind of this kind of a function, and it's kind of getting closer and closer. X is getting nearer to A, the f of x is getting closer and closer. And that's what we like to something that we like to define. Okay. And when we are defining these things, we are only allowed to use something that we know actually. Okay. So have we done something which allows us basically talk about nearness? Okay, anything else? Now, how I'm going to define that x is getting closer to A? That would one of the candidate could be the convergence actually. Okay. But for the convergence, you should have a sequence. Okay. One way obviously could be that, okay, in some sense, we have a sequence which is getting closer to what A. And as a result, it's like f of x are basically f at that sequence is getting closer to what? A. Okay. That could be potentially one of the ways to define it. So how can I write this formally, roughly? So I'm going to say that x approaches to A means okay. That's fine.